Hi everyone. Let's see how we can use Claude AI within Excel to implement k nearest neighbors classification or kNN classification, which is a very powerful and popular machine learning technique. I will ask Claude to generate a table of 20 customers, and we will see how we can use this technique to make a recommendation for a new customer. And once it generates the data, I'll explain or walk through every little detail. So I have the prompt already copied and pasted here. And it basically is asking Claude to create a table of 20 customers whose heights in inches and weights in pounds are known. And we also know what size t shirt they bought and were satisfied with. Let's say we sell t shirts of two sizes, small and large, and we have our past 20 customers whose heights and weights we have collected. And we have also collected what size t shirts they bought and were satisfied with. In other words, they were satisfied customers that didn't return the product. So we are confident in saying that those size t-shirts work for those particular customers. Now we'll also ask Claude, or in this prompt, as you can see, we're asking it to include a new customer, customer number 21, who, let's say, visits our website and doesn't know what size T-shirt is appropriate for them. So we'll ask them to enter their height and weight, and then we will use kNN classification to make a recommendation between small and large as to which one is appropriate for them. I'm also asking Claude to use something called as min-max normalization to normalize the heights and weights, and I'll talk more about it as to why we do it, and something called as Euclidean distance to calculate the distance of each customer from customer number 21. So we'll see all that. I'll walk you through those things as well once it generates the example for us. And it's saying it's going to create a comprehensive table with 20 customers plus customer number 21. And as you can see, it seems to have skipped a column, and the colors don't match. All that it'll fix by the time it says it's the table. um, it's finalized the table. So we'll see. Even the width of the columns are not um, good enough for us to be able to see everything, but it'll auto fit everything for us. It has arranged the tables in a way where it's easy to understand what it has done. That will also help me explain the concept very well. And the best part about Claude AI within Excel, as I've said in other videos, is that not only is it fast, but also if I want to understand the concept, I can just click on the cell to see what it did. We'll talk about it once it finishes the whole thing, but very nicely um, we can understand the concepts thanks to using Claude within Excel, as opposed to having a Python function which just gives us the answer without showing how or what it did to get the answer. So without any code requirement, we can implement a lot of machine learning techniques, data science techniques, and understand as well properly and enjoy as well. When understand what's going on, you can enjoy the process as well, and perhaps change things as appropriate for the situation if you understand better. It's asking me, will 3 votes uh, versus 2 votes? I will ask. I'll explain what that means very soon. But I'm going to say here, use 5 votes. We'll see what that means. Essentially, we are asking it to select the 5 nearest neighbors to customer number 21 and what size t-shirt they bought so that we can make an appropriate recommendation. Let's see, recommendation. Okay, so that's good. It has done the work for us, and it has also made a recommendation. Let's see. Yeah, the recommendation for customer number 21 is large. It's saying I can left indent this so we can see, and that's good. Let's see how it did. First, it identified the lowest height, 60, so min function, including the 21st customer. It has included in the min function, and we'll talk about why that is as well very, very soon. And max height, min weight, and max weight. So minimum height, maximum height, minimum weight, and maximum weight. So it used the min max because eventually we'll need them to standardize these values. So the idea of kNN classification is calculate the distance of all these 20 customers from the 21st customer. Now, there's a formula we can use for distance, we'll see soon. But before we use that formula, it's important for us to convert these numbers into numbers that don't have any measurement units. Because if we keep these measurement units, what will happen is, let's say instead of pounds, if you use ounces, then the distance values will be affected unfairly. So bigger numbers tend to have an unfair impact or a higher impact on the distance calculation than smaller numbers. So we don't want to have these measurement units. So what this min-max normalization does is it uses a formula where, if I click on it, easier to explain, we take the customer's height, the first customer here, 62 inches, and from that we subtract the lowest height in that column, and that is 60. Thus the shortest person in our data set, including customer number 21, is 60 inches. So from that, this 60 is subtracted, customer number one's height minus the lowest height in the column, divide by the range, so maximum minus minimum. So that's the range. So that's what it uses. In Excel there's no range function, so we have to do this max minus min like that. And notice what happened once we normalize. All these numbers are converted into values between 0 and 1. The shortest person, we saw 60, I think, somewhere. So 60 right here, customer number 3, that person's normalized height will be 0. The tallest person in the whole column will get a 1. And these numbers, based on the way we calculated, or Claude did it for us, there's no measurement unit. It's basically inches divided by inches. So there's no measurement unit. But all these values are converted to values between 0 and 1 without any measurement units. Same thing we do for the weights, normalized weights. So if I click on it, so customer number one's weight minus the smallest weight in that column, divide by the range of the weight column. So all these numbers are converted to 0 and 1. The lightest person will get a value of 0, and that's what you see here. And the heaviest person in that column gets a value of 1. It's just a coincidence that the same customer got a value of 1 for both these attributes, and 0, that customer got. So it doesn't have to be that way. They can be independent of each other, but it generated something like that for us. So it doesn't affect anything in our understanding the k nearest neighbors classification. And now what you do is calculate the distance of every customer from the new customer whom we are trying to help or make a recommendation for. And that's Euclidean distance, typically taught in high school or middle school. But if you have forgotten, it's basically square root of the difference between the heights of customer 1 and customer 21, and you square that, plus the difference between customer number 1 and customer number 21's weights, and you square that. So square root of the squared deviations of each of these customers' heights and weights from 21st customer. And you would do that for each of the customers. That's why we lock customer number 21's numbers, but we didn't lock, or Claude didn't lock other customers' values, heights and weights, normalized heights and weights. So if you click on this one, for example, how far customer, whatever that is, 1, 2, 3, 4, 5, 6, 7, customer number 7's customer 7 is from customer number 21 based on the heights and weights. And what we do after this is we identify who are the nearest customers, 5 nearest customers to customer number 21 and what size t-shirt they were happy with. And among those five nearest customers, we'll take a vote. I asked for five as a vote to see who are the five nearest neighbors. Typically, we use an odd number for it because, if, for example, if you go with four nearest neighbors, maybe two bought small size, two bought large size, it'll be hard to make a recommendation for our 21st customer, correct? So we typically go with an odd number, three or five or seven, like that. But which odd number is the best odd number, it's very hard to say. What you typically do is, if you go with k of 5, let's say, and if you're using that k of 5 to make recommendations for our new customers, and if they're satisfied with whatever they're buying, meaning not they're not returning that t-shirt, it means k of 5 is working for us. Otherwise, we'll try a different k value, or maybe change the technique altogether instead of kNN classification. And one other way of checking which k is best is, we'll do that in this case as well for k of 5. Maybe you have some known data where you know what those customers bought, what size t-shirt they bought, and we are going to use kNN classification with k of 5 to see how good this technique is working out. In other words, what's the real size t-shirt they bought, those other customers, and what is our method saying that they would buy. If there's a big difference between what they actually bought versus what our method is saying, then k of 5 is not a good number. Maybe we should change the k to maybe something else, right? So otherwise it's very hard to say what k value is the best one. And in order to implement the technique, we need to know what k we should use. It should be an odd number instead of an even number, otherwise there'll be ties, potential ties. It'll be hard to make a recommendation. So k equal to 5, it is used, and it identified the five nearest neighbors. Basically, the customer number 19 here is closest to customer number 21 based on the distance we calculated, or Claude calculated for all the customers. And in these five nearest neighbors, notice that the majority bought large, and that's why it made a recommendation for customer number 21 as large. Now, one thing I want to mention here is the way it calculated the normalized heights and weights. Notice that it used customer number 21's numbers as well, in calculating it. Sometimes people don't include these new customers. So, for example, if you see here min height, which is going into the normalized height formula, it's using customer number 21's height as well. Some people don't like it because you're including the new data into this training data. But I like to include it, and many people also do, because if you don't do it, what will happen is that if you, let's say, customer number 21 has a height which is bigger than all these other 21 customers, you will end up with a standardized or normalized value for customer number 21 as a value more than 1. And if that customer number 21 has a height which is shorter than all the other 20 customers, you'll end up with a number which is a negative value instead of between 0 and 1. You'll get those weird numbers which will make our calculations, or it'll throw off our calculations. So there seems to be a disagreement about whether to include this new customer number into these minimum and then use it for the normalization. But I prefer this one. And one last thing I want to show is maybe we'll ask Claude to come up with some known numbers for, let's say, maybe 10 customers whose heights and weights are known. And then we'll ask it to check whether k of 5 is a good number in kNN classification. So I'll say generate or create another table of, let's say, 10. Basically, we're testing our method now on these 10 customers whose heights, weights, and t-shirt size are known. test how well kNN with k equal to 5 is working in this situation. So it'll look at some discrepancies. So let's see. So it decided to do it on a different sheet, which is fine. If you're used to Python, it would split up within its function. You can do certain things to split up the data into training and testing. For example, 80% of our data we will use to train, 20% to test. But we can do that same thing here as well without any coding knowledge. So it created 10 customers as we asked it to, and we know the actual size t-shirt they bought, and it should get the recommendation now. And again, once Claude creates something, it's a good idea to always check the formulas to understand the concept as well. And for customer number one, based on the kNN method with 5 nearest neighbors, the majority it looks like is small, and the person actually bought small, so it's auto fitting the rows and columns very nicely. And it looks like it was true 100% of the time. And this may not be the case when you have a lot of customers, that you have in the original data set that you use to train. And this one, is not such a large data set. So it's giving us 100% accuracy with this. So it's saying K of 5 is working great. It's perfect is what the 100% accuracy, 0% error rate. Right. Again, that may not be the case all the time. So keep that in mind. Hopefully that was useful. And I'll see you again in another video with another data science technique without any coding requirement. A lot of things can be um, done with thanks to Claude and with the conceptual knowledge that we'll gain in the process.